Hello everyone. So in this unit we are going to build a new model for a new motion. We're going to start out with a simple one-dimensional case and eventually build to a two-dimensional case. So our one-dimensional case, about which we are going to do a lab today, is called fun with PowerPoint. Yes, we are going to look at something called free fall. Okay? Now, free falling has a very definite definition when it comes to physics. Right? It means that the only thing acting on the freely falling body is gravity. Nothing else. Okay? That means no air resistance is a big one. Okay? No air resistance, so we're going to assume everything is in a vacuum. Right? And we'll have to deal with those kinds of situations if they're not. We'll talk about that some in this unit. It means it's not while you're throwing something, right? While you're holding it in your hand and throwing it, it's not in free fall. Right? After you catch it, it's not in free fall. Right? When it hits the ground, it's not in free fall. Right? It's only when it's falling with just gravity acting on it. Okay? Very precise meaning. And we're just going to look at literally things that fall freely, okay, in this one. We're going to do a little pivot interactive on this, as you'll see. So the purpose of this first lab is twofold. We are going to determine if there is a special acceleration for objects that are falling near the surface of the Earth. And I'll only guarantee this near the surface of the Earth, right? And these are freely falling objects, so we'll be able to neglect the effects of air resistance. And then the second thing we're going to figure out is, what effect does mass have on that acceleration? Do more massive objects fall faster, slower, the same? We'll find out in this lab. Okay, so kind of two things we're going to determine here. Now, like I said, we're going to do a pivot interactive here, right, to look at free fall. This is the reason we're going to use this is because it's really well done. This is a very high speed video. Okay, in fact, this video is done at 1,500 frames per second. 1,500 frames every second. Okay, a traditional movie that you'd see in the theater might be like 30 frames per second. Okay, so this is 1,500 frames per second. And it's really important to do free fall that way because otherwise you get a lot of blurring and it's really hard to read and all that kind of stuff. I tried to do this kind of thing with my phone a year or two ago, and even when I, tried to do a high-speed video with my phone, didn't work very well. Okay, which is why I like this one. So let me show you here what's going to happen in this video. There's going to be 5 different balls which are going to be thrown upward. There you go. You'll notice here that partway up it's going to tell you about each ball. There's a green rubber ball, a lead ball, a large steel ball, a small steel ball, and a styrofoam ball that we are going to ignore in this lab. Why are we going to ignore the styrofoam ball? Because styrofoam is extremely light, right? And it's fairly big, and that means there's enough air resistance acting that it'll throw off the results. Okay, the other balls all have enough mass, or in the case of the small steel ball, while it doesn't have a ton of mass, it's really tiny, right? So there's not a lot of air resistance there. So we can essentially treat these over the small kinds of distances we're talking about here. Notice this is less than a meter, right? It's a centimeter scale. This is less than a meter they're going to go. And so we can kind of ignore the effects of air resistance here pretty well because of the types of objects we're going to use. So we're going to ignore the styrofoam ball. So they will go up. As they get closer to the top, you're going to see it's going to say moving upwards. Here it comes. There you go, moving upwards. At the highest point for one frame, it switches to top, which you probably will have a hard time even seeing, and now it's moving downwards. Right? But when you go frame by frame, you can see that. This is the part we're actually going to analyze as it falls from the top down. We're not going to worry about the part where it goes up. We'll get to that in a different lab. Okay, we're going to have freely falling objects. Now, over here in the Tools menu, right? We can turn on these much more precise scales, okay, so that we can read things. And then here's our little stopwatch thing, right, which I'm going to move over there to the right because we're not going to use the styrofoam ball. We're going to find the frame where the ball is at the highest point, and notice here in the middle, when we get it there, and this will take me a little work, right, it's going to say top. See how it says top? That means these are all at the highest point. Okay, and that is where we will zero the stopwatch, and then we'll let these objects fall. And every about 0.05 seconds, we'll stop the video and you'll measure how far it's fallen. Note, since 0 is up here, it's going to fall down, which will be negative. Right? Negative displacements. Okay, so that way we can, by controlling this video, using the frame-by-frame part here, right, using the stopwatch. All of this, by the way, that I was just saying, is in the pivot, and it's also on your lab sheet. Okay, so we're only going to do the part from the top as it falls, because it's in free fall. We're going to call, like, up and down, or two-dimensional throwing something, we're going to call that something different. We're going to call that projectile motion. But this is just free fall, because it's just falling. Okay? So follow the sheet, which will tell you exactly how to do this and set it up. There's a couple of multiple choice questions to answer, which will help make sure you understand what's going on. All right, you'll fill in your data table every 0.05 seconds, and then you got to make a position time graph, and then you got to make a velocity time graph, and then you got to answer some questions about it. And we're going to learn here about free fall, and along the way, we'll answer those questions.